Section 8.2, we're going to talk about integration by parts. If you remember in Calculus 1, we were learning about finding derivatives, and you learned a product rule. And it said if you had to take the derivative of uv, you could do that. And the product rule said when you took the derivative here, you'd have u times v prime plus v times u prime. We're going to take that and kind of apply it to integration. And that's where integration by parts comes from. Okay, so there's going to be some similarities here. Integration by parts can be written out in a couple different ways. I've got two different ways that you could represent it. The first one's basically written as function form. You've got the integral of u of x times v prime of x dx. That can be written as u of x times v of x minus, you can integrate v of x times u prime of x dx. That's very, very, very wordy. So many times it'll be written in differential version. So if you're asked to integrate u dv, you can rewrite that as uv minus the integral of v du. You might say, why would this come in handy? Well, sometimes what you're initially asked to integrate is something that you cannot do, not even using the formulas that we have. But when you rewrite it in this slightly different form, it makes it easier to integrate. And so there are times where this is going to come in very handy. There are times where within the same problem, and we'll do some examples of this even in this section, where you run through this process more than once within the same problem. The very bottom here, I've got it for definite integrals, it just tells you when you're going to be evaluating from A to B. And actually, the first example I'm going to work through here has definite integrals. So I'll show you exactly how this works. It says evaluate using integration by parts. I'm asked to find the integral from 1 to 2 of x times the natural log of x dx. Now, this is one of those where, we don't have an easy formula to just go ahead and integrate this. So integration by parts is going to come in very handy. Basically, I want to get rid of the natural log of x inside that integral. So what I'm going to do is I'm going to let u equal the natural log of x. And then u prime, or du, is going to equal 1 over x. I'm going to let my v prime be x. So v, if I integrate x, is 1/2 x squared. So you can see here the formula, it's u times v prime. So I've labeled the natural log of x as my u, the x is my v prime, and here's my dx. So now I'm going to rewrite it just following that formula. So it's going to be u times v. So in this case, it's the natural log of x times 1/2 x squared. So since I'm multiplying, I'm going to reverse the order. I'm going to write this as 1/2 x squared times the natural log of x. And because this is a definite integral, we need to evaluate this from 1 to 2. Then we're going to integrate vu prime. So again, just following the formula, vu prime. So it's going to be 1/2 x squared times 1 over x dx. Now, the x in the denominator is going to be able to cancel out here, so we're going to have a much simpler integral. But we'll get there momentarily. Let me come back here. So we're going to evaluate this from 1 to 2. So starting with the 2, we've got 1/2 times 2 squared, which is 4, times the natural log of 2, minus 1/2 times 1, because 1 squared is 1, times the natural log of 1. The natural log of 1 is 0, which takes all of this, 1/2 times 1 times the natural log of 1, that all goes to 0. Now let me keep going. I've got minus, I'm going to bring the 1/2 in front. The 1 over x and the x squared we can cancel, so we're just left with x dx inside there. And that is very easy to integrate. So 1/2 times 4 is 2, so I've got 2 times the natural log of 2, minus 1/2. When we integrate x, we get 1/2 x squared. And again, we're going to evaluate from 1 to 2. So almost done. 2 times the natural log of 2 is the same thing as the natural log of 2 to the second power. Then I've got minus 1/4 times 2 squared, which is 4, minus 1 squared, which is 1. So that's going to be the natural log of 4 minus 1/4 times 3, so minus 3/4. And that's all done.